In this video, I'm going to introduce acceleration. So we've learned what velocity is, and if we call velocity by the variable v and we use delta notation, we know that it's how fast the position variable, we know it's how fast the position variable changes, the rate of change of position. So delta x over delta t, where t represents time and the position variable is x. Now, you can talk about the rate of change of anything. You can ask for the rate of change of any variable, and the acceleration is nothing more than the rate of change of velocity. So delta v over delta t. See that? Okay. Now let's talk about what it means to have an acceleration. So a constant velocity means you're cruising down the freeway, let's say at 65 miles per hour. Your position's changing at a constant rate. Okay? Having a constant acceleration means that your speed is increasing at a constant rate. So for example, you're at a red light, the red light turns green, so you press the gas pedal on your car and you start to speed up towards the speed limit. All right? Now you're increasing it. You can feel your body pressing against the car seat. That's approximately a constant acceleration. Okay? When you drop a penny off a bridge, I don't know if you know this, but it doesn't go at a constant velocity. It actually keeps speeding up. When free fall means it's constantly speeding up. Okay? That is also an example of a acceleration. Now, acceleration doesn't have to be positive. It can also be negative. Suppose you see that the light down the road has turned red, so you start turning on the brakes on your car. You are decelerating. Okay, decelerating is just another name for a negative acceleration. Okay. Now, it's important to understand how the graphs of all of acceleration, velocity, and position are related. So let's give a sketch. Now, nothing fancy. I'm not going to put numbers. Expect too much gory detail. If we can just get the general shape, that would be good. All right. So let's say that we plot the acceleration versus time in the first graph, the velocity versus time in the second graph, and position versus time in the last graph. Okay, and then we've got the origin and some standard for the numbers on each graph. All right, so here we go. So to keep things simple, let's start with a simple acceleration that let's start with a horizontal line. All right. And I'll go ahead and give it some numbers. Let's say that goes to 4 and this is a 10. Okay? So we have an acceleration of 10. And by the way, let me give you the units. So the units of x in metric system or international system, we could use meters. Time, we would use seconds. Okay, so let's use SI units for everything. Velocity, we know, is units of meters per second. Now, acceleration has these odd units, meters per second squared. All right, where in the world did that come from? Okay, let's look at the definition of acceleration with me. Okay, let me put a box around it. Let's revisit that bad boy. Okay, so what are the units of the numerator? Okay, so I hope you would say, well, the numerator has units of meters per second in SI units at least, and the bottom in SI units would have units of second. Okay, now so meters per second divided by second, you have a fraction of a fraction. You could say that as meters per second. All right, that's one way to say it. Now, what if we multiplied the top and bottom by seconds? Okay, let me put a little line in my s's so that I know that they're not fives. Okay, if we did that, then by the rules of algebra, these s's would cancel. So what would we have left? On top we'd have just meters, and on bottom we'd have seconds times seconds. Well, that's seconds squared. Okay, so that's why we have meters per second squared for acceleration. Okay, it's basically the units you would get if you had velocity units divided by time units. Okay, all right. So there's the acceleration. Now, what does that mean for the velocity? Well, that means that the velocity every second the velocity is increasing by 10. Okay, so from 0 to 4, it's going to increase 10, then it's going to go to 20, then 30 to 40. So that's the velocity is going to go from 0 to 40 meters per second in 4 seconds. All right. What about the position? All right. Well, we know that the velocity is the slope of the position graph. So if the velocity is increasing, that means the slope is increasing. So we start out with some slope, and then the slope gets bigger and bigger and bigger and bigger. So what is something that has an increasing slope? Well, that is one example is a parabola. All right, so all of these are related. Okay, if you have a horizontal acceleration graph, you will have a linear velocity graph that's going up and to the right, and you'll have a curved position graph that's curving up. All right, think about that and why that makes sense. Okay. Now, in general, the question of how the acceleration, the velocity, and the position variables relate is a very general important problem. Okay,